Hello students, welcome to Academy, the place for mathematics and science. Dear students, from today onwards, let us focus on science. You all know that in the last class we had started the first chapter in chemistry, that is chemical reactions and equations. And do remember, this is the third period of this chapter. In the first period, we got the basic information about the chemistry, and in the second period we learned some of the important concepts related to this chapter. Once we shall go for recalling some important points, then we shall continue this chapter. In this chapter, the very first concept that we have learned was chemical reaction. Recall the definition. Yes, the process in which one or more substances undergo chemical change to form one or more new substances with new properties, right? Example, rusting of iron, digestion of food, so many are there. And next, after that, we learned how to identify whether a chemical reaction has taken place. How do you go for that? Yes, there are some observations to be made to decide whether a chemical reaction has taken place or not, and these are called characteristics of chemical reaction. They are, first one is evolution of gas, right? Second one, formation of precipitate. Third one, change in color. And fourth one, change in temperature. And fifth one is change of state of a substance. So these are the 5 observations which decide the chemical reaction. Then after this, we come across the symbolic representation of chemical reaction. What it is called? Yes, you are right. It is called chemical equation. The symbolic representation of a chemical reaction is called chemical equation. You can also define this as the method of representing or the method of writing a chemical reaction using the chemical formula of reactants and products with some symbols, right? So it is called chemical equation. What is called the shortened form of chemical reaction? It is called word equation, is it not? And in chemical equation we have 2 types. What are those? One is balanced chemical equation, another one is unbalanced chemical equation. Then here, balanced chemical equation, a chemical equation in which the number of atoms of each element on the reactant side is equal to the number of atoms of each element on the product side, right? This is balanced chemical equation. We all know that it satisfies the law of conservation of mass, right? Similarly, unbalanced chemical equation, the chemical equation in which the number of atoms of each element on the reactant side is not equal to the number of atoms of each element on the product side. Here it does not obey the law of conservation of mass. Here we used reactants and products. Just to go for recalling them. Reactants, that is the LHS part of chemical equation or chemical reaction. What it is? Yes, the chemical substances which undergo chemical reaction or the chemical substances which can take part in the chemical reaction are called reactants. Next, P, it represents product, that will be in RHS side, right? These are the new substances which are formed as a result of chemical reaction. Got it? Products are the chemical substances which are formed during a chemical reaction. Next, if a chemical equation is unbalanced, is it necessary to balance it? Yes. Why? Because to satisfy the law of conservation of mass. And to balance the chemical equation, we have different methods. But in our textbook, they have mentioned hit and trial method. Let us go for balancing a chemical equation by hit and trial method. For this, I go for taking a simple example. Here I'll write balancing a chemical equation by which method? Yes, you are right. This is hit and trial method. Then what is this hit and trial method? So I go for explaining it with a simple example. That is, we know that the reaction of iron metal with water, usually it does not react with the cold water, warm water, even hot water. Then how can we say that it reacts with water? Yes, iron reacts with water only in the form of steam. Hence we can say that iron reacts with steam. Here I'll write, when iron reacts with steam, then it is the gaseous form of water. Then it produces, yes, can you recall the products? The products are ferric oxide with the liberation of hydrogen gas. Now, this is the chemical reaction we have taken. Now, it should be converted into chemical equation, then that should be balanced by hit and trial method. Can be given in the examination for either 3 marks or 4 marks. Please do remember. But it can be expected for 3 marks. Here, the very first step, it is, we have to convert the given chemical reaction in word equation. That is the shorter form of chemical reaction. How do you go for writing this? Here they are given. When iron reacts with water, nothing but steam. Water in bracket I'll write steam. Then it produces, yes, could you tell? One is iron oxide, nothing but ferric oxide. Here I'll write ferric oxide plus hydrogen gas. This is the first step. Next, in the next step, we are going to write it in symbolic form. Step 2. This is iron. What is the atomic symbol of iron? It is Fe, and its atomicity is 1. Water. It is chemical formula is S2O. What about ferric oxide? This is Fe3O4 plus hydrogen. It is H2. Clear? So when you are balancing it by hit and trial method, first we have to write all the elements and compounds in the box. See, Fe, H2O, Fe3O4 and H2. Clear? Next, in the third step, we are going to write the number of atoms of each element on the reactant side as well as product side separately. Here, I'll go for writing that. The element, then reactant side. Reactant, it will be in the LHS part. Reactant, then product. Here, first you tell the elements that are present in which are present in this chemical equation. One is iron, second one is hydrogen, third one is oxygen. Any other element? Iron, oxygen and hydrogen. Then in the reactant side, write the number of atoms of iron. Iron, how many are there? Only 1. Hydrogen, 2 are. Oxygen, only 1. Then product side, how many iron atoms are there? Yes, 3 are there. Hydrogen, 2 are there. And oxygen, it is 4. Then do you say that it is balanced? No. Hydrogen atoms are same, but what about iron and oxygen? They are not same. Hence, it should be balanced. Dear students, in the next step, that is fourth step, we are going to choose a compound having maximum number of atoms. Clear? This is the fourth step. Step 4. What is the compound having maximum number of atoms? Yes, you are right. It is Fe3O4. Is it not? Because 3 atoms of iron, 4 atoms of oxygen, altogether 7. Here is just 3. Here is only 1. Here is 2. Fe3O4. Then an element having maximum number of atoms. Which one? Say iron has maximum 3. Oxygen has maximum 4. And element is, here I'll write, this is oxygen, O. Clear? Next, now we are going to equalize oxygen atom. Step 5. Here to balance oxygen atoms, now I am going to take both LHS and RHS, that is reactant side and product side. In here, oxygen atom is to be balanced. First, initially how much is given? Initially, there is 1 oxygen atom in LHS and 4 in RHS. Now, we are going to balance. Observe it. Here 1 is there, here 4 is there. What should be multiplied with 1 to get 4? Yes, it is 4 into 4. Here into 1. Here up. Yes, let me draw the table. Observe here. I am going to write the same chemical equation. Fe plus H2O gives rise to Fe3O4 plus H2. Let me go for putting the box for all these reactants as well as products. Observe it. What should be multiplied with oxygen? Yes, 4. Here is oxygen, LHS. I am going to multiply 4. Oxygen atom is balanced. 4 atoms of oxygen, here 4 atoms of oxygen. Observe here hydrogen. How many? 4 2s are 8. Now, oxygen is balanced. Let's go for balancing hydrogen. Here I'll write step 6. Now, we are going to balance hydrogen atom, LHS and RHS. Observe. Initially, how many hydrogen atoms are there on LHS and RHS? And after that, what should be multiplied to balance it? These two rows should be used. Observe. Here, how many hydrogen atoms are there? 2 2s are 8. RHS, only 2 is there. Right? Then what should be multiplied with 2 to get 8? Into 4. Here into 1. Hope that you have understood. Here I'll write. It is Fe plus 4H2O gives rise to Fe3O4 plus H2. Let us go for highlighting them with the box. Observe. Here we are balancing hydrogen. So on the RHS side we have to multiply 4 with the hydrogen. Now see that 4 2s are 8. Here 4 2s are 8. Hydrogen atom is balanced. Then what about iron? Now oxygen and hydrogen both are balanced. The left element is iron. Here I'll go for writing step 6. Step 7. Iron atom, then here LHS and this is RHS, that is product side. Here initial, then to balance. Here I'll write initial. How many iron atoms are there? 1. Here 3. Now what should be multiplied with 1 to get 3? It is into 3. Here into 1. Here I am going to write it. That is Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Let us go for highlighting them with a box. It is, observe this. Look here. Here, to balance iron atom, we have to multiply 3 on LHS side. Here, 3. Now count it. 3 atoms of iron. Here, 3 atoms of iron. Then, 4 2s are 8 atoms of hydrogen. Here, 4 2s are 8 atoms of hydrogen. 4 atoms of oxygen, 4 atoms of oxygen. Clear? So now it is balanced equation. I am rewriting this. 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. This is balanced chemical equation. Please go for copying from there to here. Copy. This is the equation. Just we have balanced it, right? Then once I go for writing it, oxygen. Sorry, first we balanced oxygen. Here is 4. Then hydrogen. It is 4. Then iron. It is a balanced chemical equation. Then observe this chemical equation. Here, iron and water, nothing but steam. These are the reactants. They are separated by plus sign. Similarly, here ferric oxide and hydrogen, these are the reactants. Their molecular formula are written and separated by plus sign. After writing all the reactants, we have written the arrow which indicates the direction in which the chemical reaction is taking place. Got it? And these are called the characteristics of chemical equation. Nothing but features of chemical equations. Now I'll go for writing one by one. These are the features of chemical equations. I have written all the 3 what I had explained by taking this example. So you should copy from here to here. Yes, students, again I am going to take the same chemical equation, that is 3Fe plus 4S2O gives rise to Fe3O4 plus 4S2. It is balanced chemical equation. You can make this chemical equation as more informative by following some of the indications. Then what are those indications? Observe. Here these are the reactants and these are the products. Now could you tell what is the physical state of iron? Yes, you are right, it is solid. What about the water? Here we have used steam, so you have to write gas. Then here Fe3O4, whether it is solid or liquid, it is solid. Then 4S2, hydrogen, it is in gaseous state. So by mentioning the physical state of a chemical equation, we can make it as more informative. We have some more criteria. Now I'll tell you one by one. Let me take another example. Observe it. Here, this is PbNO3 twice, lead nitrate. It is a solution which is prepared by using water. What it is called? Aqueous, right? Then similarly, potassium iodide solution is prepared by using water. Then the reaction between these two will give, yes, you are right, yellow color precipitate. What is that? It is PbI2 plus KNO3 solution. Here also you can mention this is aqueous. Aqueous means a solution prepared by using water, and this is aqueous. And what about this? This is precipitate. Please do remember precipitate. And KNO3, it is also aqueous. Now by mentioning the physical state, we can go for making this as chemical equation as more informative. Other than this, we have 2 more points. You also know that the carbon dioxide reacts with water in the presence of sunlight, and chlorophyll. What we'll get? C6H12O6, glucose plus oxygen, right? Plus H2. The equation is not balanced. Observe. Here, this reaction takes place only in the presence of sunlight and chlorophyll. Got it? Similarly, I take another simple one. You know that H2O, when assume that this is the acidified water and you will go for passing electricity into it. Just I have taken a simple example which you have learnt in your previous class. Then it gets split up into or decomposes into hydrogen and oxygen. Right? Observe here, water gets split up into hydrogen and oxygen by passing electricity. See, this is the condition. These are the conditions under which chemical reaction takes place. Let me take one more simple example. That is carbon monoxide. It reacts with water. Under what condition? Yes, when it is heated with a temperature of about 340 degrees Celsius, then we will get methyl hydroxide, CH3OH. Observe. Here sunlight, chlorophyll, electricity and 340 degrees Celsius. These are the reaction conditions under which chemical reaction takes place. Followed by mentioning the reaction condition, we can make chemical equation as more informative. Similarly, one more indication is that in some of the chemical reaction, it takes place by absorbing the heat. In some chemical reaction, during the chemical reaction, they produce heat, like calcium oxide reacts with water to produce calcium hydroxide, right? There very good amount of heat is generated. Clear? By indicating the heat changes, maybe the absorption or may give out. So these are the three ways in which a chemical equation can be made more informative. Here I am going to write the heading. The question can be given like this: how do you make a chemical equation more informative? Yes, you have to remember three important points. What is first one? First one is by indicating, yes, what are the physical changes? Here I write by indicating physical changes. Next, second one is by indicating what? By indicating the reaction conditions. And the third one is again by indicating the heat changes. Followed? Heat changes. Even I have given you one more example, that is you can recall the reaction between zinc and hydrochloric acid. There, when the reaction is taking place, you just touch the bottom of the beaker. How do you feel? You feel it is warm, right? Yeah. So these are the three important points from which we can make a chemical equation as more informative. And not only this, in case of physical conditions, whatever we have mentioned, solid as S, gas as G and liquid as L. If the gas is liberated, usually it is to be represented with upward aroma, and the precipitate is formed, then it is represented with downward aroma. Just do remember this point also. Yes. Now you will go for copying from here to here. After that, you may go for taking these examples. Dear students, balancing the chemical equation is very important concept in the examination point of view. So here, first I have taken very simple examples. let us go for balancing them. Here unbalanced equations are given. Let's move on to one by one. You are going to write the balanced chemical equation, that is balanced equation. Here I'll write Mg plus O2 gives rise to MgO. Look here. Here we are not going to follow the actual methods, the steps what we have followed in hit and trial method. Directly, these are simple equations, hence let us go for balancing them in the easiest way. First you have to take the compound having maximum number of atoms. Which one? Here Mg1, oxygen 2, here magnesium oxide total, here also 2. First, which one you will go for balancing? Here 1 atom of magnesium, here also 1 atom of magnesium. Here 2 atoms of oxygen, here only 1. Clear? First we have to take a compound having maximum number of atoms, then element having maximum number of atoms. That is oxygen 2 is there, here is 1, hence you should multiply 2. Observe, 2 atoms of oxygen, 2 atoms of oxygen. Oxygen is balanced. What about magnesium? 2 atoms of magnesium, here only 1 is there, hence it should be multiplied with 2. Now count it. 2 atoms of magnesium, 2 atoms of magnesium, 2 atoms of oxygen, 2 atoms of oxygen. So the equation is balanced. Don't you think that it is simple? Yes. Now I'll go for taking one more. It is also very simple. To balance the equation sodium plus oxygen gives rise to sodium oxide Na2O. Yes. How do you go for balancing it? Look here. Here sodium is there, only 1 atom. Here 2. Oxygen 2. Here is 1. And this compound has maximum number of atoms. Hence first we shall go for balancing it. How do you go for balancing? Look here. Here oxygen 1. Here is 2. To balance oxygen, I will go for multiplying 2. Clear? 2 atoms of oxygen, 2 atoms of oxygen. But what about sodium? 2 2s are 4. 4 atoms of oxygen. Hence, we have to multiply here 4. See that? 4 atoms of sodium. Got it? Next. Third one. Here, hydrogen and oxygen react with each other to form water. Alright. H2 plus O2 gives rise to H2O. First, select the compound having maximum number of atoms. It is water, right? And the element having maximum number of atoms. It is hydrogen. But hydrogen is already balanced. Then we can go for balancing oxygen. How many are there? Here 1. Here 2. Then what should be multiplied? 2. Clear? Oxygen is balanced. Hydrogen. 2 2s are 4. Here how many are there? 2. What should be multiplied? 2. See that? 2 2s are 4 atoms of hydrogen. 2 2s are 4 atoms of hydrogen. Oxygen 2. Here oxygen 2 atoms. Has 2 atoms. It is balanced equation. Next, we will move on to fourth one. Observe this. Hydrogen reacts with chlorine to form hydrogen chloride. Then, how do you go for balancing? Here, which one has maximum number of atoms? All. See that? Here 2, here 2, here 2. Then how do you go for balancing it? Yeah, observe it. You may take either hydrogen or chlorine. Here 2 atoms of chlorine. Here only 1 atom. What should be multiplied? This is 2. Count. 2 atoms of chlorine, 2 atoms of chlorine. Hydrogen, 2 atoms of hydrogen. Here 2 atoms of hydrogen. So this is a balanced equation. Next one. This is very important. Actually, the symbolic equation has not been given. They have given word equation. It should be converted into chemical equation. Then we have to balance it. If it is unbalanced, here I'll write. Observe. Barium chloride. What is the chemical formula of barium chloride? Yes, you are right. BaCl or Cl2. It is Cl2. You have to recall that in the very beginning class only I had given you a lot of basic information. Ba 2 plus, Cl 1 minus, crossing over charges. It is BaCl2. What about aluminium sulfate? Yes. Al 3 plus, SO4 2 minus. You can write the chemical formula as Al2 SO4 thrice. Clear up? Next, this rise to barium sulfate Ba 2 plus, SO4 2 minus. It is BaSO4 plus aluminum chloride Al 3 plus, Cl 1 minus, crossing over charges. It is AlCl3. Clear? How do you go for balancing? See, here we have simple reactants and products. Easily we balanced it. But here more number of elements are there. Hence, let us go for listing them. You find it easier for balancing. To balance them, let us go for listing the number of atoms of each element. What are the atoms? Barium is there, chlorine is there, here aluminium, then sulfur, then oxygen. Next, I'll write the number of atoms of each element on reactant side. Barium 1, chlorine 2, aluminium 2, sulfur. It's important. This 3 should be multiplied here. 3 ones are 3. Oxygen 3 fours are 12. Hope that you have understood. Then observe here in RHS, barium 1, chlorine. How many are there? 3. Then aluminium 1, sulfur 1, oxygen it is 4. Clear up? Now whether the equation is balanced? No, because only barium atoms are same but remaining are not. Hence let us go for balancing the chemical equation. Then how do you go for? What step you will follow? Take the compound having maximum number of atoms. Which one? Here 3. Here 2, 3 and 12. 12 plus 3, 15, 15 plus 2, 17. Here 1, 2, 4, 6. Here 1 plus 3, 4. So this one, aluminium sulfate, has maximum number of atoms. I am going to select it. Observe. Element having maximum number of atoms is oxygen. Here is 12. Here is 4. What should be multiplied? 3 on the RHS side. So here oxygen is here 3. Now oxygen is balanced. What about barium and sulfur? Observe, barium 3 atoms. Here is how many? Only 1. Can we write here 3? Yes. 3 atoms of barium. 3 atoms of barium. Then what about chlorine? 3 twos are 6. Here 3 is there. We can write 2. Understood? Now you count 3 atoms of barium, 3 atoms of barium. 3 twos are 6 atoms of chlorine, 2 threes are 6 atoms of chlorine. Aluminium 2, here 2 atoms of aluminum. Sulfur 3, sulfur 3. Oxygen 12, 3 fours are 12. All are balanced. Understood? This is the balanced chemical equation of this. Once I repeat, listen carefully. First you will go for listing the number of atoms of each element on reactant side and product side. Then you select a compound having maximum number of atoms. Then you should select element having maximum number of atoms. Here oxygen 12, here is 3. Hence to balance this, what should be multiplied with 4? Yes, 3. See that 4 3s are. 3 should be multiplied on RHS, that is product side. We have multiplied here. Observe it. Now look here. 3 atoms, 3 fours are 12. 12 atoms of oxygen. 12 atoms of oxygen. Next, barium is there. How many? 3. But here only 1 is there. Hence we have multiplied 3. Next, chlorine. 3 2s are 6. Here 3 is there. Hence we should multiply 2. And count aluminium. Aluminium is 2. Clear? Please go for copying from there to here and take some more examples. Now we have taken some more examples. Observe. Here, first one is sodium. Here it is a word equation. Let us convert this into chemical equation. Sodium Na. Water H2O gives rise to sodium hydroxide and hydrogen. NaOH plus H2. How do you go for balancing it? You can go for listing them. Sodium, hydrogen and oxygen. Then observe. How many atoms of sodium on LHS? 1. Hydrogen 2. Oxygen 1. RHS. Sodium 1. Oxygen it is 1. Hydrogen here is 1 and here is 2. Then on observing you can come to know that sodium and oxygen atoms are balanced. Only hydrogen is left. Hence here is 1 is there. Hence I go for multiplying it by 2. If it is multiplied by 2, 2 plus 2 4. But this will be only 2. Hence it should also be multiplied by 2. Here I will try. Observe. Na plus H2O gives rise to NaOH plus H2. Look here. First hydrogen on the right side. Here 2. Then look here. Here you can come to know that 2 atoms of sodium here is 2. Next 2 atoms of oxygen here is 1. Hence it is 2. Hydrogen 2 plus 2 here is 2 2s are 4. Clear? Once I repeat, look here, when you multiply 2 here, 2 atoms of hydrogen, here 2 atoms of hydrogen, total 4, here is 2, hence you will multiply 2, 2 2s are 4. Then oxygen, 2 atoms of oxygen is balanced. Then sodium is 2. Got it? Next I will go for one more. Here, next we have another word equation. Let us go for balancing it. First you convert this into symbolic equation. Barium chloride. It is BaCl2. Sodium sulfate. It is Na2SO4. Right? Then what about barium sulfate? It is BaSO4. You have to recall that crossing over charges. Barium sulfate Ba2 plus SO4 2 minus BaSO4. Then sodium chloride. It is NaCl. Then how do you go for balancing it? Again, see the compound having maximum number of atoms. Here is 3. Here is 2, 1, 4. How much? 7. Here 1, 1, 4, 6. Here 1 and 1, 2. Which one has maximum number of atoms? It is sodium sulfate. In that, which one has maximum number of, which element has maximum number of atoms? It is oxygen, but oxygen is already balanced. Here is 4, here is 4. Next one is sodium. Here is 2, but here is 1. Hence you can go for multiplying it by 2. Clear? Hence it is balanced. Because all the atoms are already balanced except sodium. Once I write BaCl2 plus Na2SO4 gives rise to BaSO4 plus this is 2NaCl. Hope that you have understood. See that 1 atom of barium, 1 atom, chlorine 2, sodium 2, sulfur 1, here is 1, oxygen 4, here is 4. Next, we will move on to 8th one. Eighth one. Again here also they are given word equation. Convert this into symbolic equation. Sodium hydroxide, it is NaOH. Hydrogen chloride or hydrochloric acid, HCl, gives rise to. It is just like a base and acid reaction. You are very familiar. When acid reacts with base or base reacts with acid, then it produces salt and water, right? What is that salt? It is NaCl and water. S2. Then how do you go for selecting? Yes, here if you know how to balance it directly, you can go for that, or else you can go for listing the number of atoms of each element. Here sodium, oxygen, hydrogen, then chlorine. How many atoms of sodium? 1. Oxygen, 1. Hydrogen, 1. Chlorine, 1. Here sodium, 1. Oxygen, 1. Hydrogen, 2. Chlorine, 1. Now you tell. Very simple. Sodium, oxygen, chlorine, all are balanced. Unbalanced is hydrogen. Here 2 is there. We have to multiply 2 on the left hand side. Here, alright. Wait, one more important thing. Hydrogen here is 1 plus 1. Is it not? Plus 1. Next, we have to multiply. Though all are balanced, then can we keep this as it is? Yes. Sodium 1 atom, oxygen 1, hydrogen 1 plus 1, 2. Here is 2. Chlorine 1 and RHS side is also 1. It is completely balanced. Hence you can write the balanced equation as NaOH plus HCl gives rise to NaCl plus H2O. Clear? Next, we will move on to another one. Observe. This is aluminum hydroxide. It gets split up into aluminum oxide and water. How do you go for balancing it? Let us go for listing the number of atoms of each element. Here is aluminum, oxygen and hydrogen. Aluminum how many? 1. Oxygen 3 is there. 3. Hydrogen 3. Next, aluminum here 2. Oxygen 3. Hydrogen 2. And one more oxygen is here. It is 1. Then let us go for balancing this. Which one you will go for taking? Compound is aluminum hydroxide. Which one has maximum number of atoms? It is oxygen or hydrogen, right? Because oxygen has 3, here hydrogen has 3. Here I'll rewrite AlOH thrice gives rise to Al2O3 plus H2O. Here oxygen has maximum number of atoms, but it is split up to 2 different reactants. Hence, I go for next one. Hydrogen has maximum number of atoms 3. Hence, it should be multiplied 3. If it is 3, see that 2 3s are 6, and it should be multiplied by 2. Here I write on RHS hydrogen side I should write 3. LHS hydrogen side we should write 2. Now you count how many atoms of hydrogen? 3 2s are 6. Here 2 3s are 6. 6 1s are 6. Oxygen 3 atoms of oxygen plus 3 6. Here 2 3s are 6. 6 atoms of oxygen. Aluminium 2. Here aluminium 2. Hence the equation is balanced. Clear? Yes, please go for copying from there to here. Let us go for taking another important chemical equation. We are also very familiar with this. Aqueous solution of PbNO3. Can you name this? Yes, you are right. It is lead nitrate. Then another aqueous solution of Ki. It is potassium iodide. These two aqueous solutions react with each other to form lead nitrate. Lead iodide, we can write it as PbI2 plus potassium nitrate, KNO3. This is aqueous solution, whereas this is precipitate. Later we will discuss more information about that is precipitate. Observe. Let us go for balancing it. Hence, I go for writing it as it is. Let us go for listing the number of atoms of each element. Lead, nitrogen, oxygen, potassium and iodine. Then, how many atoms of lead on reactant side? 1. Product side? 1. Nitrogen? 2. Nitrogen here? 1. Oxygen? 6. 3. And potassium? 1. Their potassium? 1. Iodine? 1. Iodine? 2. Which element has maximum number of atoms? Oxygen, right? 6. Here is 3. What should be multiplied here? 3, right? Let us go for writing the given equation as it is. PbNO3 twice plus Ki gives rise to PbI2 plus KNO3. Here is 3 has to be multiplied on the RHS. It is 3 2s are 3 2s are 6. Here I will write 2. Now count oxygen. 2 3s are 6. Here oxygen 2 3s are. Nitrogen 2 1s are 2. Here nitrogen 2. Potassium 2 atoms of potassium, but here is 1. Hence I will multiply 2 here. Next, after that 2 atoms of iodine. Here 2 atoms of iodine. Then 1 is there. So it is balanced chemical equation. We know that carbon dioxide reacts with water in the presence of sunlight and chlorophyll. Then we will get the glucose, that is C6H12O6 plus oxygen plus again water. Let us go for balancing it. First I will go for listing. Now let us go for listing the number of atoms of each element. Here carbon, oxygen, hydrogen, again oxygen is there. Carbon 1, oxygen 2 plus 1, hydrogen 2. What about in product side? Carbon 6, hydrogen 12 plus 2. Then oxygen 6 plus 2 plus 1. Then hydrogen here 12 plus here is 2. Then which one you will go for taking? Whether you go for taking oxygen or hydrogen? None of these two. Because here the number of atoms are split up to different reactants. So that is why I go for taking this. Here carbon is 1, here is 6. So we have to multiply this by 6. I will go for writing it. That is CO2 plus H2O gives rise to C6H12O6 plus O2 plus H2O. Here 6 is to be multiplied with carbon. Now count the number of oxygen atoms. Here 6 carbon atoms, here is 6. No problem at all. And oxygen 6 2s are 12. 12 plus 1, 13. But here is 6, 2 and here is 1. Total 9. Hence, how do you go for balancing the remaining? Next, we will move on to hydrogen. In hydrogen, here is 2. Here is already 2. So, 12 is there. Hence, I should multiply 12. Right? Here I am going to write it. 12. Now count it. 12 atoms of 12 twos are 24 atoms of hydrogen. Whereas in this case, here 12, but here is 2. What should be multiplied? Here 6. Now see that 6 twos are 12. Here 12 plus 12 is 24. 12 twos are 24. Then oxygen, 6 twos are 12. Here 12, total 24. Oxygen here 6, and here is 6. 6 plus 6, 12. Then it should be multiplied with 6. Now it is balanced chemical equation. It is one of the important one. Please go for copying this. Dear students, we are very familiar with the chemical formula of potassium chloride. Can you tell? You are right. KClO3. Right? What happens when it undergoes decomposition? It gets split up into, yes, we can write KCl plus O2. Right? Is it not? Let's go for balancing it. Balanced chemical equation. Very simple one it is. KClO3 gives rise to KCl plus O2. Which one has maximum number of atoms? Here is, look at this one, KClO3. And in that, oxygen has maximum number of atoms. Here is 3, here is 2. Then how do you go for? It should be multiplied by 3 and this should be 2. Now see that 2 3s are 6, 3 2s are 6 atoms of oxygen. Then potassium and chlorine, 2 atoms of chlorine, and here is only 1. I'll write 2. Then 2 atoms of chlorine, here also 2 atoms of chlorine. Now this is balanced chemical equation. Copy this one also. Okay, dear students, today we have learned how to balance the chemical equations. So as I told in the beginning, these are very important chance of giving in the examination. Please do practice them today itself with chemical formula. And now we are moving to the next part of this chapter. In the next part, again we are going to discuss about the chemical reaction. You all know that during chemical reaction, whether atoms of one element change into atoms of the other element? No, they have their own atoms. Each element has its own atoms. Similarly, is it possible to change the mass of one substance to mass of another substance? No. So totally mass is conserved, is it not? And during chemical reaction, many changes take place. When two or more substances may react with each other and one product may be formed, or there will be one reactant and it may get split up into 2 or more substances or 2 or more products. Then, and in reactant side there may be two reactants, and these may undergo chemical reaction to form 2 or more substances, nothing but products. So these changes, based on these changes, we can go for classifying chemical reactions into some types. So we will go for discussing about types of chemical reactions in tomorrow's class. Got it? And again, before concluding the class, I am reminding you, whatever we have covered, please do practice them today itself. Don't keep anything pending. And another last important thing is, in our building, little bit work is going on, so that when you are watching the video, you may get little bit disturbance. Please adjust for that. Adjust yourself and learn the concepts. So with this, let us stop the class. Thank you very much.